In this video, we will solve a question on how to find out the efficiency loss in monopoly. This question was asked in Indian Economic Series paper. The question is, the demand and cost functions of a firm are given by respectively as, we have been given the demand function is P is equal to 132 minus 8x, x denotes the output and P denotes the price. Also, we are being given the cost function is x cube minus 14x square plus 69x plus 128. We have to find out the efficiency loss of monopoly, and also we have to prove that a monopolist produces output in the elastic range of the demand function. Okay, so in this question we will be learning about the perfect competition, the output producer in the perfect competition, the output producer in the monopoly. Also by efficiency loss, what we mean, the deadweight loss caused due to the inefficiency. Okay, I will explain that very step also. Okay, here we will be using the differentiation and also the definite integral, and you bear with me and I will explain all the stuff in this question. Okay, so what we are being given, we are being given the demand function. That's the inverse demand function is P is equal to 132 minus 8x. This is our inverse demand function. The question tells us about the monopoly. Okay, and also to find out the, and let me be very clear here, since we have to find out the efficiency loss, what we call the deadweight loss. Okay, we have to find two things. First, we need to find out the output producer in case of the perfect competition, and also the output producer in case of the monopoly. Okay, so we know that what is a deadweight loss. Deadweight loss is simply the cost to the society caused by the economic efficiencies when the demand and supply functions are out of equilibrium. Okay, in case of perfect competition, demand and supply functions are in equilibrium. Okay, when we deviate from that very equilibrium, that is when we produce a monopoly output, that creates the deadweight loss. That is the cost to the society or the economic inefficiency. Okay, let me first draw a simple graph to make things clear to you. Okay, I am simply drawing a rough sketch here. So let us say we have output on the horizontal axis, price, marginal cost, marginal revenue, all stuff on the vertical axis. Okay, if I draw the inverse demand function like this, this is our average revenue function. We call this the inverse demand function also, or simply a demand curve. Okay, in case of monopoly, we have also the marginal revenue function. Okay, I'm simply trying to show you the deadweight loss, and then we will derive it here. Okay, now in case of perfect competition in case of monopoly, you know that the profit is maximized when marginal revenue and marginal cost functions intersect with each other. Okay, so let's draw the marginal cost function here with another color. अगर मैं वो set available, okay, I suppose I have that very luxury. So this is our marginal cost function. Remember, I have not drawn it in the form of linear function. The obvious you will find out in this video. Okay, now monopolist produces at a point where marginal revenue and marginal cost functions intersect with each other. So this is the point of intersection. The output producer here will denote the monopoly output. Okay, and the corresponding price that the monopolist will charge will be somewhere here. Okay, so let me write it here. P superscript M denotes the monopoly price, and let's denote this Q superscript M, that is the monopoly output. Okay, this is the output produced by the monopolist and at a price of PM. Okay, now how does the deadweight loss happen? Okay, we know that deadweight loss is the what we call the economic cost to the society when the supply and demand functions are out of equilibrium. So when they are in equilibrium, we know that in case of perfect competition, if this is our demand function, this is our supply function, so this point denotes our what we call the equilibrium point. Okay, and what happens here, and the condition is simply price is equal to marginal cost in case of perfect competition, output is at equilibrium when price is equal to marginal cost. Okay, here if I draw this line, this is our marginal cost function. Okay, this is our inverse demand function. That means this point will be the socially optimal output, that is the output generated when the supply and demand functions are in equilibrium. You know that the marginal cost in the perfect competition is actually the marginal cost function. So this denotes our supply function. This denotes the demand function. When supply and demand are at equilibrium, we get the socially optimal output. So in case of what we call the perfect competition, the output produced will be QP, that is Q superscript P. I'm just giving this notation. By the way, this is not the standard notation. So Q superscript P denotes the output produced in case of the perfect competition when we are producing at socially optimal level. Correspondingly, the price will be lower. Okay, let us say this is P superscript P. That is the price, in case of the perfect competition. Now, what about deadweight loss? What will be the deadweight loss? Here you can see, in case of perfect competition, we are producing more comparatively to the monopoly and at a lower price compared to the monopoly. Okay, so the difference between this point and this point, okay, this in fact denotes our deadweight loss. This is the cost to the society when the supply and demand functions are out of equilibrium. Here you can see. So ideally we should have produced at this point, but we are the monopolist produced at this point. So the area which is formed by these 3 points in fact denotes our efficiency loss due to monopoly. Okay, so in case of perfect competition, remember deadweight loss is in fact 0 or efficiency loss is 0. But in case of what we call the monopoly, the efficiency loss is maximum. Okay, so what will be the deadweight loss? Deadweight loss will be the area of this very region. Okay, so this was basic intuition how we have to solve this kind of question. Okay, now, so first thing is we need to find out the profit maximizing level of output and price in case of the monopoly. Okay, so let's first find. We know that in case of monopoly, profit maximizer when we equate the marginal revenue with the marginal cost. Okay, so we have this inverse demand function. We need to find out the total revenue first, then we can find out the marginal revenue. We know that total revenue is simply price into output. So let's first find out the total revenue. So total revenue, as we know, total revenue is equal to price into output, which will be equal to 132 minus 8x. To this we multiply by x, that will give us the total revenue. And let me write it here. Total revenue will be equal to 132x minus 8x square. This is our total revenue function. Now, what is marginal revenue? Marginal revenue is simply the change in the total revenue due to the change in the output. Okay, so that is simply marginal revenue is simply the change in the total revenue due to the change in the output produced. That is the derivative of the total revenue function with respect to output. Okay, so in case you are wondering, we can solve this question simply using the area of a triangle. This is not the case, and I will explain it here. We don't have a linear marginal cost function here. We have a quadratic cost function. Quadratic what I call this marginal cost function. So obviously this is not a triangle. We have two sides linear, but one side is non-linear. Okay, so we need to find out the area of this very graph. Okay, and I will explain how to find out that very stuff. So let's first concentrate on the marginal revenue, that is the derivative of the total revenue function with respect to output. Derivative of x will be 1, so we are left with 132 minus derivative of x square in the second term is 2x by power function rule. I will not go into the details. You know it pretty well if you are following my earlier videos. Okay, so we have 2 8s are 16. So this is our marginal revenue function. Okay, so you can think about this very line. Okay, this is our marginal revenue function. What about marginal cost? We know that marginal cost is simply marginal cost is simply the change in the total cost due to the change in the output. Okay, so cost function is being given us here. I will not write it here because I don't have obviously space enough to show it first here and then solve for marginal cost. Okay, so marginal cost is simply the derivative of this function with respect to x. Derivative of x cube is 3x square by power function rule, minus derivative of x square is 2x, so 2 into 14 is 28. I hope I am doing the calculation right here. Plus derivative of x in the third term is 1, we are left with 69, and derivative of a constant is obviously 0. This is our marginal cost function. Okay, so there comes the thing that I was trying to impart to you, that is we have a non-linear marginal cost function. Okay, so this is non-linear thing. If it was a linear function, then it was very easy to calculate the area of this very triangle, because the third side would also have been the linear in if we have this linear function here. Okay, but since it is not, so it's a tricky one here. Now profit is maximized when marginal revenue is in fact equal to the marginal cost. Okay, so let's equate marginal revenue with marginal cost. Okay, let me first write the marginal cost function, which is 3x square minus 28x plus 69, and we equate it with the marginal revenue function, which is 132 minus 16x. Okay, solving further. So can we, let me write it here to save the space, then I will rub that very stuff. So this is 32x square minus 28x, transposing this it becomes plus 16x. We have plus 69, transposing this here it gets subtracted, which will be 132. Okay, doing some, okay, where it is only 3x square here. Okay, so let us add or subtract the like terms here. So we have 3x square minus 28 plus 16 equal to, this is minus 12. Okay, it is minus 12x. 69 is minus 132, that is 132 69. Now that here it is 3, so it becomes this is 63, but it is negative because we have minus 132 plus 69, it is minus 63 is equal to 0. Okay, this is a quadratic function. Let us see if we can solve it further or simplify it further. So here this is divisible by 3. So what is the rule for divisibility by 3? We are to see whether a number is divisible by 3. What we do, we simply add the numbers and then, we add the digits of the number and the number formed by the addition of the digits. If that very number is divisible by 3, then then the given number is divisible by 3. Simple. Here 2 plus 1 is 3. 3 is divisible by 3. Here 6 plus 3 is 9. This is also divisible by 3. Let's divide both sides by 3. So we will get here 3, here 3, here 3, and here 3. So we get x square minus, okay, I get here x square minus 4x minus 3 2s are 6, 3 1s are 3. Okay, so this is how do we solve this. So now we can factor out using the rather simplifying using the middle term. Okay, so we should get the sum of the two numbers such that we should get two numbers such that their sum should be equal to minus 4, and the product of the same two numbers should be equal to the constant term, which is minus 21. Okay, so let us do some calculation here. If I write it here, minus 3 or 3 minus 7, so 3 minus 7, here we have 3 into minus 7, so this in fact solves our problem. 3 minus 7 is minus 4, 3 into minus 7 is 21. Okay, can we rewrite it then like this? So x square in place of minus 4x, can I write plus 3, rather what I am doing here, okay, plus 3 x, then we have minus 7x. In place of minus 21, can I write 3 into minus 7 and we set it equal to 0, okay? So bear me out, you will learn enough stuff in this question, okay? So let us factor out. So if I factor out x, I will be left with x plus 3, and if I take minus 7 here, we will get x plus 3 is equal to 0. Solving further, so let's take x minus 7 common, we are left with x plus 3, okay? Or let's take x plus 3 common, we are left with x minus 7, which implies either x minus 7 is equal to 0 or x plus 3 is equal to 0. X minus 7 is equal to 0 implies x is equal to 7, x plus 3 is equal to 0 means x is equal to minus 3, okay? So what is x? X is our output, and output cannot be negative, so we rejected this with, and we reject it graciously if it is so. So output will be equal to this stuff, okay? When I solve this question, when I solve this, I got x minus 7, x plus 3 is equal to 0. We got x is equal to 7 and x is equal to minus 3. I rejected this because output cannot be negative, okay? Let me lipper this out, okay? Sarna varna way. So this is here, okay? Let us reject it like this. So x is equal to 7. This is our monopoly output. So here we have 7. Output produced in case of monopoly is 7. Let's find out the corresponding price that the monopolist will charge. So put x is equal to 7 in this equation. So P is equal to 132 minus 8 into 7. Okay, so this is 132 minus 8 set is 56. This is up tak 56. So now look at the. So we have 132. I am really weak in doing this calculation, that sort of calculation. It's 56. Okay, so banisha to share shane you been ba sa 5 6 7 8 9 10. So we will get 76. Okay, so P is equal to 76. So monopoly, that is the monopolist will charge a price of 76. Here we have 76. Okay, now we are done with the monopoly. We need to solve for the output produced in case of perfect competition. Then we in fact can find out the efficiency loss. Okay, we have to compare that very stuff with the monopoly then. So in case of perfect competition, we know price is equal to marginal cost. Let us equate the price and marginal cost function. So P is this very stuff, 132 minus 8x, and we equated with the marginal cost that we have calculated. So this is our marginal cost function. Okay, let us use another color to make it pretty good. So we have 3x square minus 28x plus 69. Okay, we can be shamat. Sorry, we have to factor this out obviously again because we have a quadratic term here. So let's rewrite it like this: 3x square minus 28x plus 69. Transposing this, it becomes plus 8x 132. It becomes minus 132. So we have to do the factorization also, okay, to find out the roots here. So we have 3x square first, then we have minus 28x plus 8x. So this is minus 20x. I hope I am doing it correctly. Then we have 69 minus 132. 132 minus 69. Now so we have 3 here. So this is 63. Obviously it is negative. Now can we do here factorization? This is divisible by 3, this is divisible by 3, but this the middle term is not divisible by 3, so we cannot remove this coefficient. So we in fact could have used the difference, the separate in the middle term, but I don't have that enough IQ. to do this stuff. So we will use the quadratic formula here. Okay, so let us say the coefficient of x square is, okay, so there are a number of methods in solving the quadratic equation. One is the splitting middle term when we have the simple function, but when we have this kind of function, let us be very careful. We use the quadratic function. Let us say the coefficient of x square is a, coefficient of x is minus 20, let's denote by b, and constant term is c. So by quadratic formula, how do we solve? So x will be equal to minus b plus minus b square minus 4ac divided by 2a. Okay, so we have minus from the formula, then we have the coefficient of x is minus 20, so we have minus 20 again, then we have plus minus b square is minus 20 square, minus 20 square, then we have minus from the formula, then we have 4, a is 3 and c is minus 63. Very big calculation is. Then twice 2 times 3. Okay, so let's bear with me and do this calculation. Okay, so this is here plus 20. Okay, then we have plus minus 20, which one square of a negative number is positive, so this becomes 20 20s are 400, minus into we have negative 63, why it is, so it is here negative, sorry for the mistake, so minus into minus plus. Now let's do this calculation. So we have 3 3s are 9, 3 6s are 18, start karo multiply 4, 4 9s are 36, 4 8s are 32, 33, 34, 35, 36. So 4 9s are 36, 4 8s are 32, 4 1s are 4, 5 6 7, 756. So here we have plus 756 divided by 2 3s are 6. Okay, so let us solve this. 400 plus 756, 6 go 6, 5 go 5, 700 ka. So we have 1156 here. Okay, 1156. So 1156 it is square. So let us solve by divisional method. So let's make the pairs from right. So we have 3 3s are 9. Now that is 56. Now let us double this. So so let us write it like 4. Here also 4. 4 4s are 16. 4 6 are 24. This is 25. Okay, obviously this is in fact a perfect square. So we get 34 here. So can I write it like this? 20 plus minus this stuff came out to be 34. We have 6, which is equal to, either we get x is equal to 20 plus 34 divided by 6, or we get 20 minus 34 divided by 6. Okay, so if this is the case, you go 4 3 get 5, 56, 54 divided by 6, 6 1s are 6 7s are 6 8s are 6 9s are. Okay, so 6 9s are 54. So we get x is equal to 9. Here 20 minus 34, it will come out to minus 14 divided by 6. Since it is negative, we will reject this very number. So when we solve this equation, we got two values for x. That is either x is equal to 9 or x is equal to minus 14 divided by 6. So we in fact reject the negative number here. Okay, now let me rub this out. Let us find out the corresponding price in case of perfect competition. So x is equal to 9. You can see here, in case of perfect competition, we are producing more at a lower price, and let us find out that very lower price compared to monopoly. So P, simply plug x is equal to 9 in the demand function. We have 132 minus 8 into 9, so which is 132 minus 8 9s are 72. Okay, I know this very thing here. So this comes out to be 0. So this comes out to be 60. Okay, so in case of perfect competition, we are producing more output at lesser price compared to the monopoly, where we are producing less output at a higher price. That causes the deadweight loss. in the economy, what we call the economy loss, sorry, efficiency loss. Now we need to find out the deadweight loss. So we are done with all the things here. We have 7 here, we have 9 here. Now we can find out the area of this very triangle. Okay, sorry, it's not a triangle. 2 sides are linear, 1 side is non-linear. So what will be the area of this very figure? Okay, let me also explain this very thing here. So if I replicate it here, so you can see, so I have so we have like this, then we have like this, then we have like this. Okay, it's not going pretty well here, but let me. So then we have this demand function. Okay, so here we have 8, here we have 7, here we have 9. Okay, to find out, okay, so I have just taken this very thing here. So this is the triangle, it is not looking great here. Now to find out the area of this very thing, what we need to do, first we need to find out the area of this whole figure. Okay, so it will be equal to the area of this whole figure. So it is like this, the area of this whole figure, that is the area of this very triangle. Okay, so the area of this to this we subtract then this very thing. Let me show it here pretty. Okay, so from this region, when I subtract this region, I will get this region. Okay, so first we need to find out the area of this whole region. From there we subtract this region, then we will get the area of this region, that is. Okay, simple thing to say so. And let me explain it further. Since I have to find out the area of this triangular looking figure, I need to find out the area of this whole quadrilateral. Okay, from that I need to subtract this area. Okay, then I will get the upper area. It is very simple. I hope you got this. If not, इसकी गारंटी मैं नहीं ले सकता फिर. So what will be the area of this very region using the integral calculus? So the area of that very region will be, first the area of this whole region will be equal to the definite integral from 7 to 9 of this demand function. Okay, so demand function is 132 minus 8x. Okay, dx, I forget to write it here. And from this we subtract the area of this very region, that is the area of the marginal cost function, that is marginal cost was that is 3x square minus 28x plus 69. Okay, dx, that from 7 to 9. Okay, first let me see if it is visible. Not meant is I. Okay, I guess it is visible enough. Now solving it further. So let us first subtract them. Can I write it like this? So let me first rub this out. So can I rewrite it like this? From 7 to 9, 132 minus 8x minus 3x square plus 28x minus 69. Okay, dx. Solving further, so we will get 7 to 9. We have 132 minus 69. 132 minus 69. You got me 132 minus 69. Okay, 132 minus 69. 132 minus 69. Now that is so it is 63. Okay, we get 63 minus 8x plus 28x, it becomes plus 20x. Then we have minus 3x square. Okay, so we need to solve this very definite interval. Okay, let me see if I am within the limits. I guess I have the space. Okay, solving this integral. So we have the integral of 63 is 63x. Okay, by power function rule in case of integration. Then we have plus 20. Integral of x is x square bata 2 minus 3. Integral of x square is x cube bata 3. Okay, and we evaluated from lower limit to upper limit. So 3 gets cancelled, 2 1s are 2, 10s are 20. Okay, so let me rewrite it here. So I got 63x plus 10x square minus x cube. I need to evaluate it from 7 to 9. So let me do it here, this calculation. So we evaluate it first at the upper limit, then we subtract and evaluate it at lower limit. Okay, so that's why I was telling you that it's not pretty easy to calculate the area of this very region, because it is not a triangle here. Okay, remember this very. So first we evaluated at the upper limit. So we have 63, in place of x we write 9. Then we have plus 10 x square means 9 square. Then we have minus 9 cube. First we evaluated it at upper limit, then we subtract and evaluate it at lower limit. That is, in place of x's we write 7. So we have 63 into 7 plus 10 into 7 square. Then we have minus 7 cube. Okay, so let us solve it. Calculation right. Okay, let me see if I can do it here. 9 3s are 27. 9 6s are 54. So I guess it is 567 plus this 9 is 81. 81 into 10 is 810. Minus 9 is 27 into 9 is 729. Okay, this is 729. This also I know. Then we have minus. Okay, we have 7 3s are 21, 7 6s are 42. So 441 plus 7 7s are 49 into 10 is 410. Then we have 7 into 7 into 7. 7 7s are 49 into 7. You guys have 9 7s are 63. 7 4s are 28. So this is 343. So this is 3 minus 343. Okay. Solving further, 5 6 7 plus 8 1 10 minus 7 2 9 minus 4 4 1 minus 4 1 0 plus 3 4 3. Okay, because this minus is subtracted to this minus is multiplied to each of these terms. Okay, let's do the calculation here. Okay, so each equals to all. Okay, so let's add them up. So we have 7 plus 0 plus 3. 7 let me write it here 0. Okay, okay. Then we have 6 7 4 ka ba. Okay, so 2 1 abi carry. Then we have 8 9 da ka ba 3 14 15 shara. Okay, sada. Then we add the negative terms. So we have here 1 plus 9, which is 10, waka carry. Then we have 4 5 7 8. Okay, let me see. 4 5 7 8. Then we have I guess I have done some. Okay. Now we go now tage going to go here. Now tage da. Then we have 4 plus 1 go 5. We start tage over. Then we have 4 plus 4 8 or nanda ka but what's that panda. So we get 1580. Okay. I'm not sure whether this calculation is right. You can do it on the calculator whether I have done it correctly or not. So let us see what I am getting here. So this is 1720 minus 1580. Okay. But I am not sure I have done it correctly here. Somewhere there is mistake that I am doing here, and let me see where that very mistake is. Okay. 7 7s are 49. Okay. So this is not 410. This is 49. This is 9. Okay. I was thinking I have done some mistake somewhere. Let us add the negative numbers again. So we have 1 plus 9 which is 10. I have carry. Then now to 4 get trua zgai panda tagai shara. I have carry. 4 get 8. Now the ka but what's that tagai panda biya aku shara 1660. Okay. So when you solve 0 was 0 bahane shata. I guess 0 to x 0. That is the dead weight loss. The area of this very stuff came out to be 60. Okay. Now the question tells us, the next part tells us. Okay. Okay, let me solve the next part rather let me solve the next part in the next video, obviously.